Hello and welcome to the Fun Physics by Akib, in which we discuss some physics concepts and we try to find the solution and try to understand that in a very funny way. Today I got a same video for you in which we are going to discuss that why do we feel heavier or lighter in a moving lift. So basically you must have felt a stomach drop when a lift moves from a rest downwards. So basically that's not just up in fear, it's just purely a physics concept there. So basically the real question is that your actual weight, does it change or not? So basically the concept says that your actual weight never changes. Your actual weight never changes. So what then changes? But the weight you feel changes. The weight you feel, it changes. And that felt weight, that felt weight, which I told you that it keeps change, is called as apparent weight. So basically the concept rounds around the word that's apparent weight. So basically I told you that the real weight never changes, but what keeps changing is the apparent weight. And this apparent weight, it's actually the force which is exerted by the floor on you, by the floor of lift on you in this concept or in this scenario here. Okay, and in physics, this apparent weight or this force that's exerted by the floor on you, it's called as the normal reaction. Normal reaction, and which is represented by n. So basically all the thing, it rounds around this normal reaction. Okay, now we will discuss the further things, like we'll discuss now the different cases, that how this weight you feel that it keeps changing. Let's discuss the scenario first, or the case first. So we will discuss the case first, in which the lift is at rest, the lift is not moving. So basically here what, the lift is at rest. When the lift is at rest, the acceleration will be 0. So basically you are in a lift with, you have a weight of m, so you're putting a weight or a force on the floor, that's mg, and the same floor is exerting a force on you, that will be equal to the n, that's normal reaction. So according to Newton's law of motion, this mg, it will be equal to the n, as here there is no acceleration, the lift is at rest. So the normal reaction, the apparent weight, the n you feel, it's simply equal to your weight. So you feel no weight change here, you feel same or normal weight here, because here this n, that's the normal reaction, that's your apparent weight which you are feeling right now, it's equal to the mg. Okay, similarly discussing the case first, case second. Now if we discuss the case second, so in case second, what, the lift is accelerating upwards, lift is accelerating upwards. Okay, so basically what's here happening, you are standing in a lift, and now this lift, it's moving upwards with the acceleration of a. When the lift is moving with the acceleration of a, now making the free body diagram, this is you're putting a weight of mg, or you're exerting a force of mg, and the floor, it's exerting a force of n on you, and similarly acceleration is going towards upward side, applying, as the lift it's moving and the acceleration is towards the upward, applying the Newton's, that's the second law of motion. It says that the change in the force is equal to the mass into acceleration. So basically net force, it's equal to here, as the lift is moving upwards, so n must be greater than the mg, that's why the lift is moving upwards. It will be here like n minus mg is equal to mass into the acceleration, as it's saying that this n minus mg will be equal to mass into acceleration by the Newton's second law of motion. This n, this apparent weight, it will be equal to ma plus mg. So this n will be equal to m a plus g. Okay, so here this normal weight, this n, it's greater than the mg. This is the apparent weight, this